So let's solve a problem from GATE 2023 Aerospace Engineering, question number 16. So the question is, in a two-dimensional potential flow, the doublet is a limit of superposition of dash. And we have been given four options, and the option A is a uniform stream and source. Option B is a source and sink of equal length. Option C is a uniform stream and a sink. Option D is a source and a vortex. So the NPTEL reference for this particular question is the course from Fundamentals of Theoretical and Experimental Aerodynamics by Roy from IIT Kharagpur. You can see the link for the course web page. And the particular video that you want to have a look at is from week 4 and lecture number 22, which is elementary flows, doublet and point vortex and vortex sheet. The link for the particular video is also given here. You can have a look at it. So now let's go and solve this problem. So we have been given, we need to know what a doublet is. And before that, we will I'll just briefly go through some of the basic elementary flows. And we have two elementary flows before that, which is uniform flow, right? So the uniform flow will have the free stream velocity of u infinity, where this is first elementary flow, and the second one is source and sink flow. Source and sink flow. So which will have, the source will have streamlines right? See, streamlines going out from the source. It is streamlines are coming, as from the name you can understand. So all these streamlines constant, and this you can see C2 and so on. And then the sink flow is all coming into the sink, right, towards a point. So this is a sink flow. So here similarly the constant, right? So it will also have the velocity potential, which will look like right. So this will have velocity potential like this, and which will be constant 1, constant 2, right? So these are the basic two elementary flows. From this we are going to get the doublet. So what is doublet? That is our question, right? So from the name you can understand that there are two things that's happening. That's why we call it as doublet. Okay. So what is doublet? We have a uniform flow. We have a uniform flow approaching to a pair of source and sink. Okay. So pair of source and sink. So the source will have a strength and the sink will have another strength in the opposite sign. Okay. So the source and sink separated by a length of L, which will have which will have equal and opposite strength, right? Strength. Source and sink pair, sink having equal and opposite strengths separated by a finite length of L. This is called doublet. So we have a source and sink pair which will have equal strength but in opposite direction. So you can see source and sink are completely opposite, right? So that is where that opposite sign comes into picture, and it will form a dividing streamline like this. Lines, right? So these are the streamlines. This is a dividing streamline where psi will be 0. Okay, and this oval is also called Rankine oval. And just to complete this, the stream function will be calculated to be kappa by 2 pi sine theta r. How do we calculate this? This can be derived from bringing the as L tends to 0, the point and the source and sink will be in the one point, right? So then it will form a doublets like this, series of doublets like this. Okay, series of doublets like this. So from this we will use the spherical coordinate system, which is at r and theta. This is r, and at theta. From this we can calculate. So this kappa is the strength of the doublet. Strength of the doublet, and which will be denoted by length into and then the strength of the source and sink. Okay, this is just to give a overall view of the doublet, but our question is what is a doublet, right? So the doublet is source and sink pair having equal and opposite strength and separated by a finite length L. Now let's go and look. Let's have a look at the options given. Okay, so first option is the uniform stream and the source. Okay, here the sink is not coming, so this is not a correct option. And the option B is the source and the sink of equal strength, right? So this is the correct option. Equal strength and equal and opposite strength, right? That the sign is different, right? So and then uniform stream and sink is not a correct option, and a source and a vortex, we don't see any vortex. That will come in the next. If you see this video, you will get to know what the vortex is. Okay, that's all for this question. Thank you.